Hello, my name is Maria Tănăsescu, and today I will be presenting within this video a two-variable analysis between the number of concussions versus the number of retirements in the National Football League, both in the year of 2015. Before we begin, I will be providing some terms and definitions that I'll be using during my presentation. What is American football? American football is a team sport played by two separate teams of 11 players on a rectangular field with goalposts at each end. The point of the game is to score the most points in order to win. Advancing the football into the opposing team's end zone for a touchdown or kicking the ball through the opponent's goalpost for a field goal scores points. What is the NFL? The National Football League is a professional American football organization. It is made up of 32 teams split between the National Football Conference and the American Football Conference. Each conference is divided into 4-team divisions based on the team's locations. Teams play a 16-game regular season, which is divided into divisional games, intra-conference games, and inter-conference games. What is a concussion? A concussion is the most common and least serious type of traumatic brain injury that is most often caused by a sudden direct blow or bump to the head. It is one of the two statistics that we'll be looking at. What does it mean when a player retires? When a player chooses to retire, this means that they do not want to partake in their given sport anymore, in this case football, and cease to work. When a player is retired, they do not play football professionally in the NFL anymore due to their own reasons. This is the second of the statistics that we'll be looking at. To begin this presentation, I will talk about the different types of concussions that may occur due to the sport of football that may lead to a player wanting to or needing to retire. There are 3 different types of concussions, and they are graded mild, moderate, or severe depending on whether there's loss of consciousness, amnesia, and loss of equilibrium. A mild grade 1 concussion sees symptoms lasting for less than 15 minutes and no loss of consciousness. A moderate grade 2 concussion sees symptoms lasting longer than 15 minutes yet still no loss of consciousness. During a severe grade 3 concussion, the person loses consciousness and must require immediate treatment. In terms of how concussions occur in football, the blows are either helmet to helmet, helmet to ground, helmet to pad, or body/ball to the helmet, with the most frequent one being helmet to helmet. Oftentimes, if a football player experiences a severe concussion, they may choose to retire in order to focus on their health. Concussions and requirements are the 2 factors that we will be looking at today. The question that will be analyzed in depth from these 2 sets of data is, does the severity of the concussion impact the number of retirements per year for every team? Based on this question, my thesis is that if the number of concussions increases, then the number of retirements will increase as well. This is due to the fact that concussions cause serious harms to the player affected, and I believe that since the concussions can cause severe mental deficits in the future, players would choose to retire before more damage can be done. Football is a very physically demanding sport in which there's a lot of contact necessary. Should a blow be severe enough, I believe that either the player will choose to stop or they will be forced to stop playing. It is my expectation that this dataset is expected to show a positive linear association between the number of concussions and the number of retirements of the NFL teams. In other words, the more players that get concussions during the football season, the more concussions there will be as an outcome. The units that will be used are the players involved. We will be looking at the number of concussions and retirements from all 32 teams within all 8 divisions of the year of 2015. The data seen today is taken from the NFL's statistics of concussions and retirements of each given team that they provide yearly at the end of each season. There are statisticians that provide us with this raw data that take note of all the incidents and outcomes that occur on and off the field after every game for every team. At the end of each year, this data is released for future players to get the feel of which team they'd want to go to. Some players base their choice on the amount of concussions that occur every year. We will now look at each variable individually. First is the number of concussions. The number of concussions is mostly between the ranges of 3 to 9, and this is shown through the dot plot and histogram. The histogram is positively skewed with the bulk of the data within the 3 to 9 range. The quartiles are another indication of the range, with Q1 at 4, Q3 at 8, and the median at 6. This shows that the middle 50% of the data lies within the ranges of 3 to 9 concussions per team. It also gives insight as to how the data is spread, since the range from the median to Q3 is 2 people, and the range from Q1 to the median is 2 people as well. This means that the data is very evenly distributed throughout the quartiles, as the number of concussions is almost all within this range. As seen in all three graphs, there are some outliers at the upper end of the range. This is due to the fact that there are some teams that choose to play more aggressively, hence their players get concussed much more easily. Within some divisions that exist, there are teams that come from the states in which a much more aggressive behavior is demonstrated, and because the majority of the players within those teams come from those states, it is in their nature to play more aggressively as well. Concussions can become very common when players choose to attack other players in a more aggressive play. Therefore, this is why some teams act as outliers. This 3 to 9 range that is exhibited as the number of average concussions per team is due to the fact that majority of the teams see smaller occurrences of concussions as they play much more reserved than the outliers. The players do not choose to make contact or become aggressive with other players because the priorities on the field are different. There are many measures of central tendencies that can be used in order to represent the average of this data set. There's the mean at around 6.2, the median at 6, and the mode being 4 concussions per team. These measures are fairly similar and are seen through the cluster of data around those values. However, the best measure of central tendency is the mean, as it is the most accurate. The mean and the median differ, however, they both give insight into how closely related the middle part of the data is, but the median isn't affected by the outliers, whereas the mean is. The mode is usually used for non-numerical data, and it isn't the most accurate in this data set. Contrary to the measures of central tendency, the measures of spread show how the data is distributed. The measures of spread include the IQR, which is 4, the range, which is 14, and the standard deviation, which is 3.3. Unlike the measures of central tendency, these values are quite different and show different spreads. The IQR shows the spread of the middle 50% of the data, giving insight into how closely related the middle part of the data is. The range shows the spread of the data from the maximum to the minimum value, and lastly, the standard deviation shows the average deviation from each point to the mean, showing how closely clustered all the data is. In this scenario, the best measure of spread is the standard deviation because it demonstrates that the teams have a relatively wide range of amounts of concussions that players get. This is important to know because it allows us to accurately determine if the number of concussions does in fact impact the number of retirements within a certain team that given year. We will now look at the number of retirements as it is the next variable statistic. The majority of the retirements percentages for this data set are within the ranges of 0 to 3 players per team, and this can be seen within the dot plot and through the histogram. The histogram is positively skewed with the bulk of the data within the 0 to 3 range. The quartiles are another indication of the range, with Q1 at 1 and Q3 at 2, with the median being 1.4. This shows that the data is pretty evenly distributed throughout the quartiles as seen in the histogram and box and whisker plot. The number of retirements are almost all within this range. Contrary to the number of concussions, there aren't many outliers within this data. This is because retirements are usually uncommon. There's only one team that has 5 retirements, and that would be considered the upper outlier, but most of the data points fall within the normal distribution curve. There are many measures of central tendency. There's the mean at 1.4 players, the median at 1 player, and the mode at 1 player. Due to the normal distribution of this data, all of these values are similar. However, the best measure in this case is the mean because it incorporates the one outlier as well and gives an accurate representation of the average. The median is also accurate, but due to the outlier, the mean is still the better measure. The mode is also a possibility, but as mentioned before, it is usually used for non-numerical data. Measures of spread are also important in describing data sets as they relate to the distribution of the data. The measures of spread in this data are the IQR, which is 1, and the range at 5. For this dataset, there is no standard deviation. These values represent various types of spread. The IQR shows that the middle data is close together, while the range of 5 shows that the outer half of the data is more spread out. This is logical for a normal distribution. There is no standard deviation as the data sets are much too close together to devise one. Although both these measures of spread are different, the best representation of the data set is the range, because it shows that the number of retirements are close together and the spread of the data is small. It also gives us insight in predicting the outcome of the two-variable analysis. Now we'll do a two-variable analysis of these two sets of data. This is a scatter plot that compares the number of concussions with the number of retirements within football per team. As seen at the bottom of the image, the equation of line of best fit is retirement is equal to negative 0.2 concussions plus 3.3. This negative trend means that the more concussions there are, the lower the chance of players retiring per team. This may be due to the fact that the teams with the most concussions are the ones that had less severe concussions, while the other teams have had very few but more severe concussions. The y-intercept is 3.5, which in theory means that if you had an average retirement of 3.5, you'd have either 2 to 3 concussions per team. However, due to the fact that you cannot have 0.5 retirements, it is not realistic. It's important not to look at the line of best fit, but how the data fits to the line of best fit. This can be done by looking at the correlation coefficient, which is important because it tells us how accurately the line of best fit describes the data's trend. In this case, the correlation coefficient is negative 0.5, meaning that the data has a weak negative correlation. This says that the correlation values in this range usually show that there's a small amount of correlation between these two variables. Looking at the end behavior of the function, you can see that as the number of concussions continues to increase, the number of retirements decreases. Even if one team may have had a lot of concussions, if the severity of the hits is not severe, the player's chances of retiring are much less. This dataset is very realistic, as there are teams which I've mentioned before that are much more aggressive and are used to having repeated blows to the head. Some significant issues that may play a role in affecting this data are the number of players that transfer to the team that given year, as it would affect the number of retirements of that given team due to age. There are some players that want to end their careers with the team that they started. These are called one-day contracts, and it wouldn't be fair to have them retire on one team when they played the whole season on another. Another significant issue would be the physical state of the players that year, as some of them may have already been concussed from previous years. For example, Chris Borland, which played for the 49ers, retired after his rookie season with only 2 concussions in that year. However, his entire life he suffered more than 30, and they were much more severe and caused much more damage. In conclusion, there is no correlation between the number of concussions and the number of retirements. This is determined by the correlation coefficient being 0.5, showing a weak negative correlation. This means that my hypothesis that said that if the number of concussions would increase, so would the number of retirements was not correct. A possible explanation for there being no correlation is the fact that the concussions vary in severity, and having a severe concussion is very uncommon. Players that have a severe concussion may not always choose to retire, so their choice also affects the data. This is the most likely cause for the reason behind there not being any correlation. However, it's possible to extend this area of study in order to get a more accurate answer. In order to get more information, you would have to look at a wider variety of years and see if the number of retirements is impacted by grade 3 concussions rather than all concussions in general. Just because a player gets a concussion doesn't mean that they will retire, and grade 3 concussions are less common. Therefore, by looking at the most severe concussions and the amount of retirements, I believe that there will be a more positive correlation to be seen throughout the years that football has been played. Thank you for listening to my presentation.